MathLink 7, adding and subtracting fractions with unlike denominators. Our learning intentions for this is I can add fractions with different denominators, and I can subtract fractions with different denominators. And we're going to look at these two things separately because some students are better at adding the fractions than subtracting them, or vice versa. Let's take a look at the fractions 1/2 plus 1/3. If we draw it out using our pattern blocks, we can see that it's a little difficult to figure out what this total would be. We're not looking at the same pieces. So what we need to do is we need to figure out a way to turn these into the same pieces, into something that we can actually put together. And we can do this by finding an equivalent fraction. By changing these into our green triangles, we can see that 1/2 plus 1/3, or at least the red pattern block plus the blue pattern block, equals 5 of the green pattern blocks. But we still have to figure out the denominator because this still isn't one whole. How many pieces make up one whole pattern block, one of the yellow pattern blocks? How many of these green pieces make them up? When we draw it out, we can see that there are 6 pattern blocks, or 6 of the green pattern blocks, in one of the yellow pattern blocks, so we know that it's 5/6. Similarly, we can deal with the same thing if we're doing a subtraction problem. So 2/3 minus 1/2. We want 2 of the third pieces, which are the blue diamond shapes, minus 1 of the red pieces, which is our shape for half. We're dealing with different pieces here, so we need to convert these into our common piece, which, like we saw with the earlier one, is the green pattern blocks. When we replace the red and blue pattern blocks with the green triangular ones, we can see that 2/3 is equivalent to 4/6, and 1/2 is equivalent to 3/6. So 4/6 minus 3/6 leaves us with one triangle, which is, of course, 1/6 of the whole, which is the yellow pattern block. So what we've done in both of these cases is we've taken 1/2 and 1/3 and converted it into equivalent fractions of 3/6 plus 2/6 equals 5/6. And we learned when we were looking at adding fractions with similar denominators, we can do this as 3 plus 2 over 6, which equals 5/6. 3 plus 2 equals 5. Likewise, with the subtraction question, we have shown that 2/3 is the same as 4/6, and taking away 1/2 is the same as taking away 3/6. So we have 4 minus 3/6, which equals 1/6 in total. Pause for a moment and take these notes into your book. When adding fractions with different denominators, we need to put them under the same denominator. One way to do this is using fraction strips. So if you have a fraction strip that represents 1/3 and a fraction strip that represents 1/6, what we need to do is use parts that are the same size. So we can, looking at these fraction strips, we can see that the blue fraction strip can be changed into a yellow fraction strip by adding in these extra pieces, and then we see that our blue fraction strip is actually 2 pieces of the yellow fraction strip. So here we can add them up. We have 2/6 plus 1/6, and that equals 3/6. Now, always you need to turn your answer into lowest terms. So when we look at this, we can see that the 3/6 in that yellow fraction strip is the same as 1/2. So our lowest terms for our answer 3/6 becomes 1/2. And we don't have to just use fraction strips. We can actually draw our own diagrams. For the same question, we can draw out a diagram using circles or using squares. And color in our one piece. We can then draw a diagram to represent 1/6 and color in our single piece there. Just like before, we need to make sure that our diagrams represent the same. So we can draw with this particular one, we can turn this into 6. And then we can see that in both of these cases, 1/3, just like in the previous example, 1/3 is the same as 2/6. And we add 1/6 from the bottom, and we end up with 3/6, which when you look at the pictures, you can see represents 1/2 of the whole. So we bring it down to lowest terms of 1/2. Please pause and copy down your notes. Just as in adding, we can use fraction strips or we can draw diagrams that will help us figure out subtraction problems. So 1/2 minus 2/5. Again, like with addition, we need to use pieces that are the same size. So we need to turn both of these fraction strips into strips that have the same size pieces. By turning them into tenths, we can see that 1/2 is the same as 5/10, and 2/5 is the same as 4/10. If we take away all of this, we are left with only 1/10, which is in lowest terms. Instead of using fraction strips, which are the strips of paper that your teacher can provide, you can also draw it out with the diagram, either with circles or with squares, as I've done here. Again, you're still going to need to turn it into equivalent fractions. So our fifths have to be turned into tenths, whether you're doing it with the square or with the circle. Likewise, our halves are going to have to be turned into fifths, or sorry, tenths. When we look at the diagrams that we draw, we can see that we're taking 4/5 away, so this amount is gone. Or in our picture with our rectangle, this section is gone, which leaves us in both cases with 1/10 left. And 1/10, of course, is lowest terms. Pause and take your notes. The other way to figure out adding and subtracting fractions with different denominators, of course, is to find a common denominator just through the math. So if we look at 2 and 7, you find the multiples of 7, because it's the biggest number, are 7. That's not divisible by 2. But 14, which is the next multiple of 7, is divisible by 2. So we can multiply our denominator by 2. Whatever we do to the bottom, we do to the top. 2 times 7 equals 14. So we multiply our denominator by 7 and our numerator by 7. And then we have 7/14 plus 2/14. And we can do it the same way we do when we have like denominators. 7 plus 2 over 14 is 9 over 14. Using our divisibility rules, 9 and 14 don't have any common factors, so we know that this is our lowest terms. Same thing with subtraction. We look at the multiples of 3. 3, 6, 9, 12. We look at the multiples of 4, 4, 8, and 12. We've come up with a common multiple. So 3 times 4 equals 12. Whatever you do to the bottom, you do to the top. 4 times 3 equals 12. Whatever you do to the bottom, you do to the top. And we have 4 over 12 minus 3 over 12. We can do this the same way as we did before. 4 minus 3 over 12 equals 1 over 12. And 1 over any denominator is always going to be lowest terms. So our key ideas for this lesson are when you are adding or subtracting fractions using models, fraction strips, or diagrams, you need to use pieces of the same size. Likewise, when you're adding or subtracting fractions with unlike or different denominators, use a common denominator so that you're dealing with fractions of the same type, of the same denominator. And you can do that by looking at the multiples of each of the denominators and find one that they have in common. You can estimate when adding or subtracting fractions by comparing them to 0, 1/2, or 1, or if it's larger than 1, 1.5. Those are benchmarks that we are pretty familiar with. We know what 0 looks like, we know what 1 looks like, and we know what 1/2 looks like approximately. Please copy down the key ideas and then do your communicate the ideas.